let's look at this problem. Remember, we're now looking at how to find the nth term of the expression of an nth term of a quadratic sequence. Okay, now this is a typical example. The question says find an expression for the nth term of the sequence that starts 10, 14, 20, 28. Okay, to begin with, our n number of terms, we have it to be 1, 2, 3, 4. If you look at this, this is not a linear sequence. This is not an arithmetic sequence, and it's neither an arithmetic sequence nor a geometric sequence. Okay, this is a quadratic sequence. Now, having brought out this number of terms, so the terms themselves, or the term itself, will be, so when our n is 1, we have it to be 10. When our n is 2, we have it to be 14. When our n is 3, we have it to be 20. When our n is 4, we have it to be 28. Okay, now for a quadratic sequence, the expression for the n term starts with n square. So it has to start with n square. Since the expression for the nth term, we have n square as its beginning, so let's bring n square here. Remember, we are dealing with quadratic sequence, and quadratic sequence or quadratic expression is an expression in which the highest power of x is 2. Just like here, the power of x of n here is 2. Okay, so when we have n square here, so n square, when n is 1, will give us 1 square is give us what? 1. And when n is 2, n square will be 2 square, will give us what? 4. When n is 3, n square will be 3 square, will give us what? 9. When n is 4, n square will be 4 square, could give us what? 16. The term itself will be 10, 14, 12, 20, and we have 28. Now, when you do the basic subtraction, 10 minus 1 give us 9, 14 minus 4 give us 10, 20 minus 9 give us 11, 28 minus 16 give us 12. Looking at this, the expression for the nth term for this quadratic sequence will be, remember, we want to get an expression in such a way that when you plug in the respective values of n, you will get back to each of these terms. Now, looking at this critically, we can deduce that the expression for the nth term will be n square. Now, let's say when you add plus n, let's add plus 8 and see what it's going to give us. So this is critical. You have to employ your critical thinking. Let's use this expression and see if it's valid. When our n is 1, when we plug in 1 for n respectively, so 1 square give us 1. 1 plus 1 give us 2. 2 plus 8 give us this 10. So it's valid for this when n is 1. Now when n is 2, when we plug in 2 here, 2 square give us 4. 4 plus 2 will give us 6. Now 6 plus 8 will give us 14. So it's valid for this one. Now when n is 3, 3 square will give us 9. Alright, 9 plus 3 give us 12. 12 plus 8 give us 20. It's valid for this one. Now when n is 4, 4 square is 16. 16 plus 4, 20. 20 plus 8, 28. So it's valid for each of the terms here, right? So that means this expression is correct. So this is basically how you can find the nth term expression for a quadratic sequence.